In this lesson, we'll discuss how to compare graphs, as well as how to create a graph or graphs to compare two given sets of data. Notes will be important for this, so please have them handy. Remember, you can review the lesson on note-taking titled Note-Taking Suggestions for Describing Distributions if you feel you need to. Okay, on the back of your note page, you should have wrote a little bit from a separate lesson about describing graphs with your socks. Let's add a little bit to that. So, how to compare? If you're given two different graphs, you will often be asked to compare them. First, remember your socks O. You still want to talk about the shape, the outliers, the center, the spread, and anything obvious about the graphs. But now, when comparing graphs, you need to use your ER words. Higher, lower, greater, lesser. If you don't use your ER words, you're really not comparing. You could do a great job describing graph number 1 and describing graph number 2 without ever comparing the graphs. But if you do that, you won't have a complete answer. Let's try an example. In example 1, the Department of Agriculture at a university was interested in determining whether a preservative was effective in reducing discoloration in frozen strawberries. A sample of 50 ripe strawberries was prepared for freezing. Then the sample was randomly divided into two groups of 25. Each strawberry was placed into a small plastic bag. The 25 bags in the control group were sealed. The preservative was added to the 25 bags containing the strawberries in the treatment group, and then those bags were sealed. All bags were stored at 0 degrees Celsius for a period of 6 months. At the end of this time, after the strawberries were thawed, a technician rated each strawberry's discoloration from 1 to 10, with a low score indicating little discoloration. The dot plots show the distribution of discoloration ratings for the control and the treatment groups. Compare the dot plots. Does the preservative seem to be effective? Pause the video to work on this. Click play when you're ready to move on. Looking at the graph, there are three main things we can talk about. We can talk about the different shapes, we can talk about the different centers, and we could talk about the different spreads. There doesn't seem to be any outliers, but remember what the question is asking. Is the preservative effective? Let's start with the shape. The shapes are similar. Or the control group is more skewed left than the treatment group. Next, outliers. As we said, there doesn't appear to be any outliers in the strawberries. What about the center? The center of the discoloration ratings for the treatment group looks to be lower than the center of the discoloration ratings for the control group. As you can see on the graphs, the centers are definitely different, which will be important when we're talking about its effectiveness. What about the spread? The spreads of both distributions are very similar. The treatment group has a slightly higher range of discoloration than the control group. So does the preservative seem to be effective? Well, we talked about in the treatment group that the center was lower. Remember, lower numbers are good in terms of preservative. So the treatment group seems to have better looking strawberries than the control group based on the fact that the center of the discoloration rating was lower. So since the group of strawberries with the preservative or the treatment group has a lower center of discoloration than the control group, it looks like the preservative could be effective. Now, what if I wanted to compare the data in just one graph? So far, we've talked about comparing two different graphs. Using a back-to-back stem plot is your answer. Let's try this with example 2. Remember this data table about literacy rates from another lesson? We talked about the female literacy rates in one graph and the male literacy rates in another graph. Well, one way that we can compare these graphs is to make two different ones like we did, or we can put them together in a back-to-back stem plot. You have the stems in the middle from 2 to 9, and then you have one set of data on one side of the stems and the other set of data on the other side of the stems. Again, don't forget your key. And then this is actually the most important part. Label the data. Without the labels, I don't know which numbers belong to which group. So what you need to do is label the side that represents females and the side that represents males. In this case, you see both the female and the male literacy rates in one graph as one picture. Sometimes it's easier to compare the graphs this way. Now let's test what you've learned so far with a check for understanding. Given two sets of data as shown, I want you to create a back-to-back stem plot or dot plot, and then compare the graphs. The data is a set of basketball players' heights for a season in 2010 and a set of soccer players' heights in 2010. Make a graph that compares the data and then compare them in a few sentences. Pause the video to try this on your own. Hit play when you're ready to move on. For this solution, I decided to do a back-to-back stem plot. If you didn't want to do that and you wanted to do two separate dot plots or two separate stem plots, that's okay. But as you can see, I've made the stem plot with basketball and soccer. In this stem plot, I let 6/5 represent 65 inches. That tells you my key. And then, looking at the graphs, the soccer heights seem to be more skewed than the basketball heights, which look fairly symmetric. The center for the basketball heights seem to be higher than the center for the soccer heights. Not too surprising. And the spreads of both data are roughly the same. And there doesn't seem to be any outliers in either data set. Now here's the wrap-up. After this lesson, you should be able to do the following. Given two sets of data, create a graph or graphs that will compare them. And given two graphs, compare the distributions. Don't forget your socks and your ER words. We will cover comparing other types of graphs in other lessons. So we've talked about dot plots and stem plots for quantitative data. In other lessons, we'll learn about histograms and box and whisker plots. You'll use those for large data sets. That's it for this lesson on comparing graphs. Remember, you could review this video as many times as needed for better understanding. Thanks for watching.